Hello students, Professor Nugent here. In this video we're going to introduce instrumental variables. Instrumental variables is another approach to resolving an omitted variables or measurement error problem. Consider the regression model y equals beta naught plus beta 1 times x1 plus beta 2 times x2 plus e, and assume that we do not have data on x2, so that x2 is left out of the equation. Then the equation becomes the following. We have y equals beta naught plus beta 1 times x1 plus u, where x2 is contained in u. Thus far, we have looked at three options for resolving or for addressing the situation. We can ignore the problem and suffer the consequences of a biased estimate of beta 1. We can look for and use a proxy for x2. And if we have panel data and x2 is constant over time, then we can use fixed effects. Now, instrumental variables is an approach that may help when none of these other approaches are suitable by bringing a new variable, we're going to call that new variable z, into our consideration, given that this variable z meets certain assumptions. So we're going to introduce the instrument z, and z needs to meet certain assumptions. We're going to write these down as two assumptions, and sometimes we'll talk about these assumptions as being three separate assumptions. First, the covariance between z and u is equal to 0, meaning that z, the instrument z, is exogenous in the above equation. Okay, so z is exogenous. We're going to have another, I'm going to write this as a second, and we're going to write the third. Second, z is excluded from the above equation, and we're going to call that equation a structural equation. We'll see that later. So z should have no partial effect on y. Assumptions 1 and 2 go together. Third, the covariance between x and z is not equal to 0, meaning that z is a relevant instrument. So we have three assumptions that we need to be able to make about our instrument: the exogeneity assumption, the exclusion assumption, and the relevance assumption. Let's look at a quick example to help us think about this case. We may be thinking about a wage model where we have log of wage, which is equal to beta naught plus beta 1 times education plus u. And in this case, the covariance between education and u will not be equal to 0, because we think that ability will be contained within u, ability is correlated with education, and so we have omitted variable bias. A potential instrumental variable, Z, could be the number of siblings. Why does the number of siblings work? Well, having more siblings is correlated with lower average levels of education and is not necessarily correlated with ability, the attribute in U. So Z is not necessarily correlated with U, but is correlated with education. So Z is going to work as a good instrument for us. So how are we going to use this instrument Z? Well, we're going to use Z to identify the variation in education that is exogenous to U. In other words, we're going to partial out the variation in education that is exogenous to U as a linear combination of Z, and leave aside the variation in education that is correlated to U. And in that way, we can obtain an unbiased estimate of beta 1 using our instrument Z. Stay tuned to the next video, and we will write down how we identify beta 1 using our instrument Z and how we go about inference.